Hello, in this video we'll do checkpoint 5.21. They want us to find the area enclosed inside the cardioid. R is equal to 3 minus 3 sine theta, and outside of the cardioid R is equal to 1 plus sine theta. So these are cardioids. I believe the first one is going to be a cardioid. If we take a look at it, I think it looks like it starts off with 3. It starts off with a distance of 3 here. Maybe we'll make it a little bit bigger. And then it goes to 0 and then comes back out to 3. And then it has a 6. So this goes all the way down to 6 at 3 pi over 2, or I guess negative pi over 2 if you look at it from that point of view. And then the other cardioid is a plus, so it's going to be an upside down cardioid. It's going to starts off at 1, and so it gets bigger, it goes to 2, and then comes back down, and then it has something like that. All right, so those are our two cardioids. We want to be inside of this one and outside of the other one. And I think one other important aspect that we will need from this is the angle that this makes. And so it looks like we're looking at these two angles. And if we're looking for the area, maybe we can just do half of that. Just do this half. And just know that we're going to start here at an angle of minus pi over 2, and then whatever this angle is. We can set the r's equal to each other, and then solve for theta, or we can try to graph it. I have a graph of that in Desmos, and so let's take a quick look at the graph in Desmos. Here's the graph in Desmos. I have a slider in for A, the angle of theta, which is the angle that we're looking at. By the way, that's just a neat way of trying to find out, trying to draw out the angle theta is equal to something for different values of R. In any case, I'm going to guess that this is going to be pi over 6. And so if I type pi over 6 in for the value of A, you'll see that it does look like it hits that intersection. But again, you can set those two things equal, those two functions equal to each other to see that you're going to get pi over 6 as your value. So let's just mark this as pi over 6. And so the area, if you remember the area, we can find the area of R using a double integral and integrating over R, and we're going to put 1 in for the value or for the function. And the way we're going to do this is just we're going to go from minus pi over 2 to pi over 6, and then we're going to double it. All right, so there's a couple of things in play here. One is that fact that we're going to double the area. 2 is that we're going to go in the polar coordinates, and going to polar coordinates we're going to need some limits. So our R limits are going to be from the lesser function, and we're measuring the R limits going outward from the origin, and so the lesser function is going to be the 1, that function 1 minus sine theta. And let's make that fit a little bit better. And then the larger function is 3 minus, or 3 plus. One of them is a minus. This is a plus, this is a minus. So these are the two functions that we're dealing with, and those are the radial distances, and the lesser function and the larger function. And then our theta, we're going to just go from minus pi over 2 to pi over 6. Now we have to be careful not to go from pi over 6 to like 5 pi over 6, because that's going to give us a negative value. It's going to give us the stuff that's inside or on the other side. We can't go from pi over 6, from 5 pi over 6. We can't go from 5 pi over 6 to positive pi over 6, because that looks like, it feels like it's going to go backwards. And so we have to go in some sort of from positive to negative order in dealing with the angles. And so we have to go into the negative. You can go to a negative, I think 7 pi over 6 to pi over 6. That's probably one of the better ways to do it, but the best way to do it, I think, is to cut it in half and just go from negative pi over 2 to 0 to pi over 6. Well, we'll skip the 0 part and just go to pi over 6. All right, we're going to set up our integral now, our double integral. 1, it's going to be 1, but then the dA business, since we're going to go into polar coordinates, remember, we'll have the extra r that would pop up. And then your r limits for the dRs can go from minus, or from 1 plus sine theta to 3 minus 3 sine theta. And then your theta limits go from 0, from minus pi over 2 to pi over 6. Okay, so yet another one of these integrals that you cannot separate, so you have to do it from the inside out. And so we'll start off by saying that this is going to be r squared. Well, let's put the integral out here, minus pi over 2 to pi over 6. And this is going to be r squared over 2. Oh, remember that we had to multiply everything by 2. Let's put that in a different color just so we can remember how that stands out, that this is a 2, and so this thing has a 2 out in front, since we're doubling it. Now the integral of r is 1/2 r squared, and then we're going to evaluate this r from these functions: 1 plus sine theta, 3 minus 3 sine theta. And then after we evaluate that, we'll put in theta. So what will we have? The 2's and the 2 and the 1/2 will cancel, and then we will be left with the integral from minus pi over 2 to pi over 6. And then we're going to evaluate at 3 minus 3 sine theta. We're going to square that, and then we'll subtract 1 plus sine theta, and then we'll square that, do theta. Okay, now what's going to happen here is that you FOIL this out, you combine things, and then you'll have a constant term, you'll have a term with just a sine, and then you'll have a term with a sine squared. So the sine squared is going to be a half angle integral problem that I don't really want to deal with. And so I'm just going to go ahead and put everything into Wolfram Alpha to the computer and have the computer do the work for me. Okay, let me share that screen, and it should look something like this. This looks like the integral. If we follow the integral, it's the integral of r dr d theta from r limits going from 1 plus sine theta to 3 minus 3 sine theta, and then our limits are for theta is going to go negative pi over 2 to pi over 6. So this is just without the 2. Let's put the 2 in here. So let's say 2 times, and then run it again and see that our result is just going to be I don't know why they have the 2 sitting out here, but it's just going to be 9 times root 3 plus 8 pi. So let's just write down the results here. This will be 9 times square root of 3 plus 8 pi, and a decimal approximation would be about 40.7212. All right, so that's our Wolfram approach, or that's our graphing calculator approach, or integral calculator approach to get the answer. What is, to me, what is the most important part is setting up this integral. And so I think once you get that set up, then, you know, in the homework you're free to use whatever you want to use, but it is good practice to try to figure out some of these integrals by hand, although some of them could be tedious. I think if you have time, it's just good to practice. All right, I hope that helps.